Hello and welcome to 11.5, the area of irregular polygons. We are on page 5 of the notes. So you can turn there, find this page. So this is our vocabulary at the top. It's kind of nice we don't have, to look at the definitions because we've got pictures. So what is this shape right here? Well, it's pretty easy to figure that out. It's a triangle, but it's also a regular polygon. So we have a regular polygon. So think of this as it could be a 4-sided, 5-sided, 6-sided shape, but we just have a triangle for the example. All right, anytime you have a line going from the center of the polygon to one of the vertices, it's going to be called a radius. Right, so you'll see that word today. This right here, you've got your triangle. This point right here is the center. Right, and then right here is the central angle, which we will be using a lot today. It's our central angle. And then here, this is a new word that you have not heard before. When I say it, it kind of sounds like I have a lisp. It is an apothem. Yes, that's what it's called. So it's that dotted line. What's very important about the apothem is that it's from the center of the polygon to one of the sides. It's not to one of the vertices. Okay? So those are the vocabulary that you'll hear me say. If I say one of those, you don't know what it means, you can always refer back to this and know what's going on. All right, this is the first page. Example 1, 2, and 3 are going to be when we have special right triangles, such as 30, 60, 90 triangles, or a 45, 45, 90 triangle. So 30, 60, 90 triangles, remember it looks like this. 60, 30. So we will be using that in the problem. Most of these, they're a lot of work, but you're doing the same thing over and over again. So it's not ultra confusing. Move that off the screen. Okay, your first step will always be find the central angle. So this is the formula for central angle. 360 divided by 2 times the number of sides. This is your first step, always, always, always. So 360 divided by 2 times 3 because it's a triangle. And 360 divided by 6, 60 degrees. What did we just find? We found the central angle of this. These will not always be drawn in, the little baby triangles, but this is for this one. So on the homework, for example, you may have to draw your own picture and draw your little baby triangles. So that's this angle right here. It's the angle at the center of the circle when we draw a right triangle. Why is 360 divided by 2 times the number of sides? Because 2 of these triangles fit on this side. So you can make 6 of these tiny triangles in here. All right, and then 14 is the radius. So what we have going on right here is a 30, 60, 90 triangle. We have the radius, and we want to figure out these other 2 sides. Why do we want to figure those out? Well, this is the formula for area of a regular polygon. 1/2 AP. And if you think about it, we learned a word today that is A, the apothem. P, if you think about it, what's a P word that we use in geometry? Hopefully you're thinking of it. It's perimeter. Alright, so those are the 2 things we need. We need the apothem and the perimeter, and then we have the area of this. So, we have to use this side to find these 2 sides, so we can ultimately find the perimeter. So I'm going to label this, because it's a 30, 60, 90 triangle. This should be a review. You've done it before. We have 2n equals 14. So n is going to be 7. So if n is 7, we know that our apothem, and notice the difference in area is an uppercase A, the apothem is a lowercase a, so that's how you keep those separate. The apothem is 7. Now we got to figure out our perimeter. If n is 7, so this side, 7, and the long leg is n root 3, you just need to plug 7 in right there. So our long leg is 7 root 3. But we care about the length of the entire side. So if just from here to here is 7 root 3, here to here is 7 root 3, we've got to figure out what the whole side of that is, of that shape. Here's what you need to make sure you do. You need to multiply 7 root 3 times 2, so it becomes 14 root 3. Do not make that 14 root 6, don't make it 14 root 9, don't do anything crazy. 14 root 3, you are only going to change the whole number. Do not touch the square root, because you're multiplying it by 2, which is a whole number. You're not multiplying it by the square root of 2. All right? You want the length from here to here. If half of it's 7 root 3, the whole thing's 14 root 3. Okay, I just want to get that through to you. So 14 root 3 is the length of one side. How many sides are there? 3. So to find the perimeter, we've got to figure out 14 root 3 times the number of sides. So that's where our 42 root 3 comes in for our perimeter. All right, awesome. Now we have everything we need to solve. So we've got our area equals 1/2 AP. So area is 1/2 times the apothem times the perimeter. So if you remember, when you're putting this in the calculator, you are just putting the whole numbers in, because that root 3 is just going to stay there. We want it in simplified radical form. So we're going to put 1/2 times 7 times 42 in the calculator. We're going to figure out that that is 147 times the square root of 3 inches squared. So yeah, is that a lot? It is. The more you do it, the easier it is. These really just take practice, and then you get used to it. Okay, let's look at the next one. Still using special right triangles. But let's figure out what the central angle is. 360 divided by 2n is going to be 45. Well, look at that. We got a 45, 45, 90 triangle. Okay, so we can label it like this: n, 2n, n root 2. Let me draw that so we are not confused. It's going to be n root 2. It's going to be n and n. I'm really bad at drawing triangles. Just make it really thick line. There we go. Okay, that's terrible. Oh well. So we've got n, and n root 2 for the hypotenuse. All right, this is one of the shortcuts that we learned. If you don't remember that shortcut, I'll show you the math behind it to solve for n. But the shortcut, if you remember, is anytime the hypotenuse is a whole number on a 45, 45, 90, you cut it in half and put a root 2 on. So the ends would be 3 root 2. If you want to solve for it the math way, you get 6 equals n root 2. So you need to divide by root 2 on both sides. So n equals 6 divided by square root of 2. You cannot have this on the bottom. So you have to rationalize to get that out of there. And you just multiply by whatever's on the bottom. 6 root 2 over 2, because the square root cancels out. And then you get 3 root 2. So it's much easier if you just know the formula, or you know the shortcut, because then you'll realize that this is 3 root 2 and that the apothem is 3 root 2. They're both 3 root 2. Alright, so we have our A, 3 root 2. Our perimeter, half of one of the sides, 3 root 2. So if we're trying to find the whole thing, we need to double 3 root 2. So 6 root 2. So are we using this 6 anymore at all? No, we're not using it anymore. All we care about is the apothem and the perimeter. We just use this 6 to solve for those two things. So our perimeter is the side, the entire side, 6 root 2, times the number of sides, 24 root 2. Now we have our apothem, and we have our perimeter. We can plug it into our formula. So 1/2 AP formula. So our area is going to be 1/2 times the apothem times the perimeter. All right. Now, we got something weird. We've got 3 root 2 times 24 root 2. So when we multiply those together, the square root is actually going to disappear. So, what I'm going to do is I'm going to multiply my whole numbers first. So 3 times 24 is 72. Then if I multiply my radicals, the square root of 2 times the square root of 2 is 2. And so we've got 1/2 times 72 times 2. So if you put all this in the calculator, you'll notice that this 2 and that 1/2, they cancel out, so your final answer is 72. All right. I know I'm going pretty fast here, but just make sure you get everything down that I wrote. And if you're confused on any of this, you can always rewatch the video or rewind. Okay? Let's move on. Example 3. This is the last type of special right triangle one you will use. So if you notice, our central angle has been 60, it's been 45. This one is going to be 30, and I'll show you why it's 30. So it's 360 divided by 2 times the number of sides. So this is 30. So we're using our 30, 60, 90 triangle again. Anytime you have a hexagon, you're going to use the 30, 60, 90 triangle. Anytime you have a quadrilateral, you're going to use 45, 45, 90. Anytime you have a triangle, you're going to use the 30, 60, 90 when we're talking about regular polygons. All right, let's figure out what we have first. So do we have a radius, do we have an apothem, or do we have a side? We have a side. So from here to here, it's 10. So half of that is going to be 5. 5 goes right there. Now we need to label our triangle. In root 3, 2n, and n. So remember our steps. We label the triangle. We solve for n. We'll check this out. N, oh, that's in root 3. Sorry. N is already solved for. We know that n is 5. So that's really nice. So we just need to figure out what we need. Do we need the 2n or do we need the in root 3? We need the apothem. We don't care about this radius. All right, so our apothem is going to be 5, so we plug in 5 for n, times the square root of 3. Our perimeter, we already have one of the sides. Super nice. We have one of the sides is 10, and then there's 6 sides because it's a hexagon. So our perimeter is going to be 60. This one is the easiest one. It comes together really nicely. So for our 1/2 AP formula, we have what we need. So our area is going to be 1/2 times 5 root 3 times 60. So really all we need to do is multiply 5 and 60 and cut it in half. So 300 divided by 2. And put a root 3 on it. All right, 3 down, 2 to go. So those are all the cases. These right here are all the cases when you're using special right triangles. You can only use special right triangles on triangles, or equilateral triangles, quadrilaterals, and hexagons. All right, next page. We're actually going to skip number 4. I know you know how to plug numbers into a formula. All right. Here's an example of one where the triangle is not drawn in. So you have to do this on your own. And on the homework, you will have to do this on your own. There we go. We have this triangle right here. Find the area of this regular polygon. We drew the triangle in. We have to figure out 360 divided by 2n. Remember, that's the first step always. 360 divided by 2 times the number side. This is a weird one. It's a heptagon. So it's 7 sides. So this heptagon is going to have, oops, it's 25.7. 25.7 is the central angle of the heptagon. So remember what you're looking for when you do this 360 divided by 2n. That's pretty important that you know what's going on. The 25.7 is our central angle. Well, crap. We cannot use special right triangles anymore. So you have to think, when in this class did we have one angle and one side and we solved for the rest of the triangle? I hope you're remembering this. Some old hippie caught another hippie tripping on whatever you want to call it. Apples, acid, asphalt, any one of those. So some old hippie caught another hippie tripping on acid. We're going to use trig to solve for this. Alright, hopefully we remember the steps of trig. So we need to first figure out, what do we want to solve for? Do we care about this radius? No, we don't. We want to solve for the side so we can ultimately find the perimeter, because we want the apothem, which we have, and the perimeter. So what did I do? I circled our angle. I circled the angle that we have. And then we need to label the two sides that we have. Do not label the radius. We don't care about it. It's going to confuse you. We have opposite, adjacent, and hypotenuse. Those three things, we've got to pick two of them and label them. Well, there's the right angle. So this purple line is the hypotenuse. So we don't want to write that down. We want to write the adjacent and the opposite. So here's our angle. Which one is closer? Which one is adjacent to this angle? Yeah, it's 5 right here. And then which one is on the opposite side of the triangle? Which one's further away from the central angle? It's that one. So the opposite is the x. The adjacent is the A. So we've got to figure out which one of these three do not have the hypotenuse. Ding, ding, ding. It is tangent. So hopefully our mind is remembering how to do this. We have tangent of our angle. Always going to be tangent of your angle. 25.7. And that's going to be equal to the opposite side over the adjacent. So that's why it's important that you label the sides and you don't get them mixed up. Your opposite side is x. Your adjacent side is 5. And then, oh man, we're going back to everything we've learned in geometry. So if you remember, we talked about when x is on top, we do something. When x is on bottom, we do the opposite. So it's either multiply or divide. And when x is on top, you're going to multiply. Hopefully you remember that. So in your calculator, you can put this. So 5 times tangent of 25.7, which you have this on your phones. You can just take your phone, turn it to the side, and you actually have this. Let me turn the brightness up. So you have this, which is super nice. Get out of the history. So you can do 5 times tangent 25.7. Now you can do this at home. Look at that. So 2.4 is going to be the answer to this. So the length of half of our side is 2.4. We only have half the side. We're trying to find the perimeter. So the entire side would be double that, right? Don't forget that step. That's the main thing that I see people get wrong. And it's frustrating because they do everything else right. They just get the perimeter wrong. So, let's finish this problem up. We have 1/2 AP. Our apothem is 5. We know that. Our perimeter, we've got to take 4.5. Excuse me, we got to take 4.8 and multiply it by the number of sides. So perimeter is 4.8 times the number of sides, 7. I'll just tell you what that is. It's 33.6. And then this actually ends up being really nice. It comes out to be a whole number, 84 centimeters squared. Okay. Yes, these problems take a long time, but you're doing the same thing every single time. So it's not ultra tricky. Let's look at the very last one. Find the area of this regular polygon. So I'm going to draw in my triangle. Remember, you are going to have to do this. You will have to draw in your triangle every time. 360 divided by 2 times the number of sides. That's a stop sign, right? There's 8 sides in the stop sign. 22.5. What an ugly number. But oh well. That's what we're going to use. And then you've got to figure out what you have. What are you given? You're given the length of this side. So half of that is going to be 4. And then you think to yourself, what else do I need? Well, the perimeter we can figure out. It's just 8 times 8. So we have the perimeter. What do we need? We need the apothem. We don't need the radius. All right, so we're going to circle our central angle. And then we want to label these sides. We don't have the hypotenuse. We don't care about the hypotenuse, so we're not going to label it. But we do have the opposite and adjacent sides. Okay, so we're going to use tangent again. Tangent of our angle, which is 22.5, is going to be equal to the opposite side, 4, over the adjacent side, x. Whoa, check it out. We're dividing this time. Last time we multiplied because x was on top. This time we're going to divide. So this is what I want it to look like in your calculator. Do not put this on top. You will get it wrong. Always put the number in first. If you just remember that simple thing, put the number in first, you won't get it wrong. So I'll find this on here. 4 divided by tangent. There. 22.5. 9.6565, blah, 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 blah. I'm going to round it to the nearest tenth, which is 9.7. This is not 9.6. If you don't know how to round, we got problems. 9.6 because 5 rounds the 6 up. Okay? So x is 7. What is x? It's our apothem. Our apothem is... I'm going crazy. Our apothem is 9.7. X is 9.7. The apothem and x are the same thing. All right, so we need our perimeter, which is 8 times 8 equals 64. We have all the things we need. Yay! Our area, our capital A area is 1/2 9.7 times 64. And when we put that in the calculator, I'll do it for you. It's 310.4. We don't have any units, so we just say units squared. And that's how you do it. Just one little hint. If you are ever given the radius, you are going to have to do trig twice. So here we gave you the side of the triangle. Here we gave you the apothem. If you're given the radius, you're going to have to use sine and cosine. And you're going to have to do trig twice. So just letting you know, if you get to that, that's what you have to do. All right, thanks for watching.